In this section, we'll learn about binomial distribution. It is one of the most widely used discrete probability distribution, which relies on the Bernoulli process, which has the following characteristics. 1. The experiment has 2 or more consecutive trials, so the trials must be done many times and must be done consecutively. 2. Each trial has 2 possible outcomes, success or failure. For example, sales pitch could be successful or unsuccessful. Manufacturing items could be either defective or not defective. Students going for a lecture could be late or not late. Or a respondent in a survey could be married or not married. The third point is that each trial must be independent, meaning the outcome of one trial does not affect the outcome of another. Finally, the last point, the probability of success must remain the same for each trial. If all the conditions are met, then the probability of X successes in N trials is given by this formula P of X, where N is the number of trials, X is the number of successes for the experiment, little p is the probability of success in each trial, and 1 minus p is the probability of failure in each trial. And so X can range from 0 success all the way to N successes. Also, if something follows the binomial distribution, then it would have a mean mu of n times p, a variance sigma squared of n times p times 1 minus p, and the standard deviation sigma of square root of the variance. In this example, we are told that the national data indicates that 20% of the population are asthmatic. A random sample of 3 people are selected, and we are to find the expected value and the standard deviation of X, given that X is the number of asthmatics. Well, there are 2 possible outcomes in this case. Either the person is asthmatic or not asthmatic. So that qualifies to be a binomial distribution. For binomial, the 2 most crucial pieces of info are the N and the P. Here, the sample size N is equal to 3, and the probability P is equal to 0.2. To get the expected value, or the mean, use the formula N times P. Substitute 3 times 0.2 to get the expected value of 0.6. To get the standard deviation, we have to first find the variance using the formula N times P times 1 minus P. Substitute the N and the P's to get the variance as 0.48. Finally, to get the standard deviation, take the square root of the variance to get 0.693. In part B, we are asked to find the probability that out of the 3 people, none, 1, or 2, or 3 are asthmatic. Since this is a binomial distribution, we use this formula to find the probability, bearing in mind that n is equal to 3 and little p is equal to 0.2. For part 1, the probability that none is asthmatic means that we want p of x equal to 0. Using this formula, change all the p's to 0.2, all the n's to 3, and all the x's to 0, to get the answer as 0.512. In part 2, everything remains unchanged, except that we now want the probability that one person is asthmatic. So we want p of x equal to 1. Using this formula, change the x's to 1 this time, and you'll get the answer as 0.384. For p of 2, change the x's to 2 to get the answer as 0.096. And for p of 3, change the x's to 3 to get the answer as 0.008. In part C1, we need the probability that at least 2 are asthmatic. At least 2 means a minimum of 2. On the other hand, we only have a maximum of 3 people. So we are really looking at the case of 2 asthmatics or the case of 3 asthmatics. So that's P of 2 plus P of 3. Substitute x equal to 2 and x equal to 3 into the binomial formula accordingly, and we should get 0.104 as the answer. In part C2, we need the probability that at most 2 are asthmatic. At most 2 means we want a maximum of 2. That means we could have 0 asthmatic, or 1 asthmatic, or 2 asthmatics. That's a lot of cases. To get around it, we take the total possible outcomes, which has a maximum probability of 1, and minus out the one case that we don't want, which is the probability of 3 asthmatics. Substitute x equal to 3 into the binomial formula, and we should get 0.992 as the answer. In part D, we are asked to draw the probability distribution. To do that, we first tabulate all the different possibilities for x from 0, 1, 2 to 3. From part B, we have already found the probability for each of the x's. So just tabulate them and check that everything adds up to 1, which is the maximum probability. Once that is in place, plot the number of asthmatics on the x-axis and plot the probability on the y-axis. Now when x is equal to 0, probability is 0.512. When x is equal to 1, probability is 0.384. When x is equal to 2, probability is 0.096. And when x is equal to 3, probability is 0.008. And we have got ourselves the probability distribution.